Okay, hello. My name is Muhammad Ajapar, computer system, second assignment. So I'm going to explain my coding, which is going to use the simple bubble sort. I'm just going to start. First, I'm going to build the project and then I'm going to debug. Okay, so we have the register over here and the memory. So I already opened the input and output data location memory. So first of all, I'm going to put R0 32. This is for the my outermost my outermost sorting that's going to be used as a counter. And now I load the input data into R1. So now my R1 has the input data location, which is this to until -12, and then I'm going to continue. And this R2 is for a counter for I'm going to transfer the input data into the output data to be sorted. And then I'm going to take R4 as the first address of the input data to be used at the transfer function. And then R3 is I'm going to put the output data into R3, which is A80, which is right now it's 0. So for the first function, I'm going to transfer the input data into the output data so that after the transfer, I will just sort the output data in the ascending order. So over here, I'm going to load the element of the first input into R5, which is 2. And then I'm going to store the element into the first location of output data. So I'm going to repeat the process until everything is entered into the output data. So this is the second number, which is 0. Now we're going to input the third element of input data, which is um, right now it's -7. So -7 is already entered. So now I'm going to fasten the process until all of the input data is entered into the output data location, which may take a while. -16, 15, 13, 1, 4, -3, 14, -8, -10, -15, 6, -13, -5, -9, 12, tomorrow, -11. Okay, now the transfer process is almost done. So the final number has been input, and now we're going to jump into the outer loop function to start the sorting process. So I'm going to put a 31 into an index as a index for comparison, the counter for comparison in the inner loop. So right now F6 is already got 31. 31 on the R6, and then now I will load the new output data, which is the one that has the same same data as the input data into R11. So now we're gonna use R11, the new output data, to sort in the ascending order. So R7 is going to have the second elements of second element's address of output data. So now we're going to jump into the inner loop. So now I'm going to load R8, register 8 with the first number of the output data, which is 2, and then R9 is going to be 0, which is the second element of output data, and then we're going to do a comparison over here. So if R8 is less than 0, then we don't need to do this move exchange location process. We're just going to jump into loop 3, but because our R8 is 2 and our R9 is 0, so 2 is bigger than 0, we're going to change the location, change the value, and then after we change the value, we jump to loop 3 function to store into the output data location. So I'm going to store the first element as 0 because we already changed it before. Now after we store, we're going to continue the process for the second and third element. Okay, so now we're going to, as we can see at the memory section, it's going to compare between 2 and -7. So 2 and -7, -7 is lower than 2, so it's going to change the location, and then it's going to store into the output data. So we are going to do this comparison process for 31 times. Okay, I'm going to fasten up the process. The process of comparison, the main point of the comparison is that we are going to bring the biggest number between all of the data, which is 15, into the last location of the output data. That's the main purpose of the inner loop. So over here we can see the 15 is going to be changed location and transferred to be at the final location of the address. It might take a while. After 15 is going to be at the end, we are going to start back the comparison process for 31 more times. So now 15 is almost at the end. Oh, it's almost 8 minutes. Okay, this is too long, I guess. Okay, so we're almost there. 15 at the end. Okay, so now when after we got 15 at the end, then it's just going to start compare back between first and second and third, until it's find the biggest number in the next one to be bring into its position after comparison. So now we already started the second outermost, and I'm just going to finish it over here. And now we can see at the memory location, this is the sorted in ascending order of the output data, and this is the original input, start from A0 1 0 0 1 0 0 A00 to this is the input data, which is the unsorted until over here, and this is the sorted data. Okay, thank you very much.